In this video, we will create a simple circuit using the OR gate. The OR gates are commonly used for backup power systems, security systems, and control systems. This type of gate outputs a high signal only when either or both input signals are high. They are also often paired with other logic gates such as the AND gate, NOT gate, to perform complex tasks, especially in the field of electronics engineering. Our objectives in this activity are to familiarize ourselves with the breadboard and other basic electronic components, and number 2, to demonstrate and simulate the basic function of the OR gate and its applications. Before we begin, let's review some basic safety precautions when handling electronics. Number 1, use personal protective equipment when necessary. Examples include rubber gloves and safety goggles. Number 2, avoid wearing static-prone clothing and ground yourself properly to prevent harm or damage to components. Number 3, handle all components correctly and with care, especially the sharp pins of the electronic parts. And lastly, unplug the power supply when not in use. As for me, I am not wearing a PP right now because we are only handling a 5-volt battery supply, which is not dangerous when handling with our bare hands. Now, let's prepare the following electronic components and materials before we start. We need one 5-volt battery. In our case, we use a Raspberry Pi hooked to a power bank. We also need one large breadboard, some male-to-male connecting wires, 6 5mm LEDs, 6 2 kΩ 1/4 watt resistors. Alternatively, we use here 100 ohm 1/4 watt resistors due to the absence of the 2 kΩ resistors. One 74LS32 IC, 3 4-pin buttons, and an optional multimeter. Since I don't have a multimeter on hand, I'll just simulate my circuit. Let us begin. Step 1. While optional, I encourage you to prepare a circuit diagram to quickly and efficiently have the installation of components on the breadboard. Step 2. Prepare your breadboard and decide where to connect the positive and ground lines. Step 3. Place the 74LS32 IC and the 4-pin buttons carefully according to the circuit diagram. Handle the components with the sharp sides away from you to avoid injury. Step 4. Pair each of your 6 LEDs with the 2 kΩ 1/4 watt resistors and place them on the breadboard according to the circuit diagram. Step 5. Once all the essential electronic components are in place, use the male-to-male connecting wires to connect them, following the circuit diagram. A helpful tip is to color code the wires uniquely for each LED to easily troubleshoot any issues with misplaced components. Keep in mind that each button has a corresponding LED, which acts as the indicator of that switch being turned on. Step 6. Connect the positive and negative sides of the battery to the appropriate lines of the breadboard. Lastly, review all circuit components if you encounter any errors in the assembly. Now that the circuit is assembled, what do we observe? As shown in the circuit diagram, all the buttons from D0 to D2 have a corresponding indicator LED, which turns on when its associated button is pressed. A signal from D0, D1, or both makes the OR gate output a signal turning LED 4 and 5 on. This is due to the nature of an OR gate to output a high signal when at least one high input signal is present. Moreover, as we can see in the circuit diagram, the combination of the OR gate C and D acts as the 3-input OR gate. Hence, any signal from D0, D1, D2, and combination of these will turn on LED 6. In real-world applications, the OR logic gate is widely used in automation and control systems. Great examples include a home security system which detects any motion or suspicious activities being sensed. In addition, robotics also use these logic gates to retrieve various data or inputs to execute a specific task. This logic gate, combined with others, are truly the fundamental building blocks in the field of electronics engineering. This marks the end of the video. I hope you learned something about the OR logic gate, its function, and its applications. See you in the next video.